everyone. In this section, we will review the concepts of random variables and probability distributions for random variables. The learning objectives for this session are to list the properties and types of random variables, to understand the meaning of probability distribution functions for discrete and continuous variables, and to describe the cumulative distribution function. We also want to define the mean and the variance for a probability distribution function. So a few terms for the first page. A random variable is a variable which assumes for its values the outcome of a random experiment. And that means an experiment where we cannot predict what we're going to get. Now, a random variable assumes only real numbers, and the set of all possible values of a random variable, x, is called its range space. We can define events in the range space, and their probabilities can be found. And we have some examples. So for example, a random variable could be the number that shows when a die is thrown. It would be 1, 2, 3, 4, 5, or 6. The number of heads you get when a coin is tossed 3 times. We could have the weight of sugar in a 1-pound bag, or maybe the amount of snowfall in January in Peoria, Illinois. Could have the life of a car battery in hours, or the number of bad products in a sample of 20 products. These are all random variables. And there's 2 types of random variables, either discrete random variables or continuous. A discrete random variable is one that takes a finite, which means countably infinite number of possible values. Whereas a continuous random variable is one that takes an infinite number of possible values. So therefore, normally you take the value within some kind of interval. So let's look at our examples one more time. The number that shows when a die is thrown. Here we can have numbers 1 to 6. So this is a discrete random variable. What about the number of heads? If we toss we have 3 tosses, and we have the random variable as x is the number of heads. What kind of variable is that? You can have 0 heads, 1 head, 2 head, or 3 heads. So we also have a discrete random variable. Let's say we're looking at a bag of sugar. We're interested in the weight. A bag of sugar. What is that? Is that discrete or continuous? Now, obviously you might have a scale that only weighs down to a gram, but in this case you can have any minute different weight. So this is a continuous. You're not limited to like 1 gram, 2 gram, 3 grams. You could have theoretically any number in between if your scale could measure carefully enough. And here we have the snowfall, the same thing. You can have any amount of snowfall, from no snowfall to a very large amount, and as long as your measurement is accurate enough, you can measure to a very infinitely accurate value. So the amount of snowfall would be continuous. Life of a car battery in hours. If you're counting by hours, 1 hour, 2 hour, that would be discrete. But if you're talking about the life of a car battery, then that could take almost any value. That could down to seconds, picoseconds. The number of bad products in a sample of 20, though. There you're counting the number of bad products, which we do a lot in quality engineering. That's a discrete random variable. Now let's go back to Munich, where we celebrate the Oktoberfest in the last week or so of September. The random variables are, as we said, they're used to represent populations with variability. And so let's pretend that we are managing one of the big tents at the Oktoberfest. And we're going to let x, our random variable, equal the height of the guests entering our tent at Oktoberfest in Munich. So clearly for height, this is a continuous random variable because we can have any height. And if we wanted to start measuring the people, we can plot a graph of the height versus the frequency of the people that come into our tent. And here you can see that people are coming in. Some people are taller and some people are shorter. And the rest of them lie somewhere in between. So we make a mark on our graph, on our chart, every time someone comes through the tent, depending on how tall they are. Now, we come across random variables every day. In this case, maybe it's not so interesting to know the height of the people coming through the tent, but often decisions have to be made involving these variables. And therefore, it is necessary to have a good knowledge of their behavior. For an example, you have a BMW car dealer. It's also here in Munich. BMW, Bayerische Motorwerke. They want to know the number of cars a certain model that should be ordered for the next month. Now, the demand in that example for the cars in a certain month is a random variable. The dealer doesn't know exactly how many cars he or she is going to sell. But they would want to know how the demand is behaving in order to understand how many cars they should order. So in other words, the dealer would like to know the possible values of his or her random variable. Is he going to sell 1 million cars or 5 cars next month? And how likely is each value to occur? The BMW dealer needs the probability distribution of the random variable demand. As we will see in this course, the outcomes of many processes we deal with in quality engineering are random variables. And if we can then have a model of our random variable, and here I have the model of the heights, we can then use that to help us to predict the process outputs based on the model of the process inputs. So we try to model the process outputs using distributions appropriate to their processes. We try to model the process inputs, and predictions using these models enable evaluation of the capability of the processes to meet customer requirements and help us in improving the quality of the performance of our production. So if our prediction then indicates that the product will not meet customer standards, then the same models would then provide directions for making improvements so that we would have an adequate capability in our production.